Okay, hello everybody. This is the second time we're doing this, so just going to kind of ease into it to make sure everything's working okay. There's definitely a delay between when I start doing things here and to make sure that everything else is working. As you can see, I forgot to turn off my monitor audio here, just kind of loop through there. But it looks like we're kind of recording through here, which is good. Got a couple of viewers, which is great. If you're there and you're logged into the chat, definitely just say hello and make sure everything you can hear everything okay. As always, I kind of like to start off the show just mentioning that this is kind of new to me, and I don't have the most powerful laptop, and I'm using an open source software called OBS, Open Broadcast Software, which has crashed several times when I've used it. So if for some reason the feed goes down, definitely just wait for a little bit. I just have to restart the program and everything will be good to go. So I actually just finished dinner. Hey, Mark, good to see you. Good to see you. Glad you're joining. I feel like this will be a really good chat for Mark, actually, because Mark I know is a web developer. So, although maybe it won't be that good because he'll know everything that I'm about to say. So, I just ate dinner and I forgot to go through my checklist here. So let me just make sure everything is good. External chat, okay, good. That's all good. Um, okay, so before I get started, I'm going to mention this a couple times, but again, if you are not subscribed and you haven't hit the bell icon, definitely do that. One, it obviously helps me out, but two, you'll get notified when these things happen. Again, we're going to try to do this weekly, every Thursday night at 8 p.m. Obviously, with everything that's going on with COVID-19, people are indoors more. I know a lot of students are doing obviously the remote classes, but want another outlet to something to do. And not to mention for me, I love doing this. This is I had a really great time last time. So I really appreciate you guys joining in. So if you haven't already, definitely subscribe, hit the bell icon. You'll be good to go. So a couple other things I want to mention. Um, Yeah, okay. So last time I got asked a question about imposter syndrome, and I kind of got into this huge rant about other software engineers and computer scientists and people in general making you feel like an imposter or making you feel like you don't know enough. And I do realize after I kind of said that it kind of gave a very negative tone and negative vibe to the software engineering computer science community, and that's not really the case. Like there are definitely some bad apples here and there, but in general, even though I say things like that a lot, those are very few select people. Whereas the majority of the software engineering computer science world, I know myself, are very supportive and very inviting and very collaborative and really want to help each other out. It's a great group of people actually. So I didn't want that to scare anybody off, and not to mention again the people who do say things like, "Oh, you don't know what Angular is," or you don't know the difference between Angular V2 and V3 or anything like this. Again, I think that's coming from a genuine place of excitement. They're just excited. They know it and they want to share it, and it's cool stuff. And sometimes it's hard in this world to figure out a nice way to tell somebody, "Oh, if you don't know this, you should know this." It's pretty cool, right? So it's hard to gauge sometimes if people really understand things or not, and especially when we deal with software development, there's definitely a lot of things there. So yeah, so that's it. Other than that, again, I just really want to say that I had a really fun time last stream. So really happy anybody who joined, and definitely if you guys can help me spread the word. Again, to any of the groups that you're in, chat groups, classes, other students. I'd love for this to spread just beyond Ottawa. I kind of advertise it to Ottawa U, Carleton, and Algonquin, and even just through LinkedIn and Twitter. I would love if this kind of went a little further than this. And even after we go back, to a relatively normal life where hopefully we're not socially distancing for that long, they say a couple months, but even after that, I think this is a good format because one, it's recorded, so people can rewatch it, which is good. Two, people don't have to like I know what it's like if you're on campus and you have a bunch of classes and then you go home, what it's like to try to go back in onto campus, right? So this way you can watch it from home, which is really good. So I really think that's a positive aspect. And this also gives a lot of flexibility. Mark suggested last week that maybe we have some guests on, stuff like that. And I'm definitely open to that. I'm kind of figuring out a little bit again the technicalities of broadcasting Skype and all that stuff through this. It's apparently not that hard. And then I just have to figure out how to do that a little bit, and decide which guests I want on, stuff like that. So I definitely am open to ideas like that. I definitely am going to stick right now to the format of some kind of formal lecture in the beginning and some Q&A at the end. So if you have any questions, I mean, feel free to type them as you go. And I mean, this is what YouTube Live is all about, and Facebook Live and all that stuff like that, just people chatting and stuff like that. So don't be afraid to ask questions as you go. But do know that it's kind of hard for me sometimes to switch camera angles and watch the chat and present and all this stuff like that. So if I miss your comments, I miss your questions, definitely, I apologize for that. There was a great comment from one of the students that I've met, Sean. He mentioned how using units in your variable names is a really good idea, and this was all in the talk of semantics. And that's something that I missed in the chat, and that's a great comment. So recently I've been developing an app that integrates with Stripe. So for those of you who don't know what Stripe is basically a payment processing service. So if you want to accept credit cards on your web application, or your mobile application or whatever, you can use Stripe, and you basically interact with Stripe to actually process real money. It's always really cool when you actually deal with real money in software. It's very interesting, actually. But anyway, so there are a lot of complications in dealing with decimal and floating point math in software engineering. So they actually store all their values in cents. And actually, most monetary companies do this because it's a lot easier to deal with integers than it is to deal with floats and decimals and all this stuff like that. So I recently had to update my app to also store things in cents. And in doing that, again, creating that good semantics, I added amount in cents to the name of the variable and the column name and stuff like that. So really, really good point that Sean brought up with semantics. I still still very strongly believe in what I was talking about in terms of semantics. I know there were some concerns that were brought up, but then you have to change and refactor and deprecation and all this stuff. But it's definitely a very important thing, and I actually realize that I see it a lot in a lot of the big frameworks. Again, when you see a framework like Ruby on Rails change a variable name that they've changed a configuration variable name that they've had for ages, it's because it's starting to lose its meaning, right? They could have kept the variable name the same, but changing the name to give it better semantics is a very important thing. So if you didn't get to see that last time, go watch my video about semantics. It's last week's edition. You'll be good to go. And then the last thing before I get started is I want to clarify some maybe confusion in terms of advertising my Casey Lee Live brand. So Casey Lee Live is basically anything that involves me live streaming. And currently there are two versions of it. There's the software edition, and right now the Untitled edition, like the original Casey Lee Live. So Casey Lee Live actually started as me playing acoustic guitar, playing concerts basically, and I'm actually hosting one this Saturday. So that's what Casey Lee Live is. Casey Lee Live Software Edition is what this is right now. So if you're confused about Casey Lee Live is happening this Saturday, it's not the Software Edition. That's more me just playing guitar or whatever. So if you're in it for the software, look out for the Software Edition. I'm trying to brand the thumbnails a little bit differently, so that's a little bit less confusing as well. So anyways, that now you know. Okay, so let's just jump into it. Let's jump into today's lecture, or today's formal lesson part, basically. So April 2nd, 2020, Casey Lee Software Edition. Welcome, everybody. Today, we are going to talk about full stack web development and what a full stack developer is. I think there's a lot of people who see job postings for front-end developer or back-end developer, and they'll see some job postings for full stack developer. They'll see a lot of these things. And sometimes the context of what that is used in, whether we're talking about client-server applications, whether we're talking about desktop applications, whether we're talking about web applications, mobile applications, that can change the meaning of what front end, back end, and full stack mean. Now, I will say, in my world, because I'm in the web development world, I tend to see full stack applied to web more often than not. But front end and back end are definitely used in other contexts. I don't see full stack a lot in other worlds, but it does exist for sure, for sure. So one thing I want to talk about today is what being a full stack developer means in web development specifically. Okay, and when you come across job postings for a front end developer, back end developer, or full stack developer, one thing you want to be careful of is make sure that, you know, if you like what you hear today, make sure that they are indeed talking about web development. Now, I will say, again, I haven't browsed the job market very frequently, but I wouldn't be surprised if the majority of the time when we're talking full stack front end, back end, a good chunk of the time that is in web development. So this will be a great lesson for people who have either never done web development before or have just started to dive into web development, and they toss around terms like front end and back end, and because they're kind of, again, trying to chat with other people, but they don't really quite know what everything means. And I'll be honest, this is a topic that's not very, very clearly defined in a lot of cases. Sometimes you get some back end that bleeds into front end and front end that bleeds into back end. You definitely get some of that going on. So it's not all super clear cut, but there are some general rules that you can follow. And again, if you're brand new to web development or you're just getting into web development and you want to be a bit more confident in when somebody tells you, are you a front end developer? Are you a back end developer? Are you a full stack developer? Or when you're in the job market and you're looking for these jobs, you'll understand what those are. So that's what today is all about, is what is a full stack developer, and kind of buried in that lesson is what is a front end developer and what is a back end developer, all in the context of web development. Okay, so before we start this talk, we have to understand a very basic principle of how the web works. Now, I teach this in my first year class, so for those of you who've taken my first year class, you'll know this. And I've actually given another talk. If you look for a YouTube video called A Primer to Web Development, or a Primer to Web Development, you'll see how this works as well. I've given this talk over and over again, and I've told many, many people this because it's one of the fundamental things that everything else in the web is based on. And if it's one thing that you take home from today, it's this lesson. And I always tell this people, and it's all about the request response cycle. Here's what it looks like. How the web works is you basically have a computer. So on your laptop or your desktop or whatever, you open a browser, right? So whether that's Safari, Chrome, Internet Explorer, Edge, whatever it is, you open up a browser. Okay, that's how you browse the web and interact with the web, right? So what actually goes on there is when you type in a URL and hit enter, or when you submit a form, or when you click on a link, or when you, there's a couple other things that you can do, okay? When you do those things, you create a web request, okay? So that request is this arrow right here, okay? So you create a web request that goes out into the internet and reaches out to a web server. Now, a web server is a computer that's sitting out there on the internet, okay? It could be virtual, it could be physical, it literally could be a laptop that's hooked up to the internet in some person's room. Okay, it is a computer that's running out there somewhere on the internet, and it has some magic inside that computer. We don't know yet what's going on in there, but it will then return you a response. Okay, so you made a request, and it will return you a response. And that response can be many things, actually. One of the primary things it can be are code files, okay? And the code that would exist in these files are one of three languages, okay? HTML, CSS, and JavaScript, okay? HTML, CSS, and JavaScript are the three languages that could come back in the form of a code file to the browser, okay? Another thing that a web server can send back is data. Okay, it could send back code that has some logic in it, for loops, if conditions, templates, these kind of things, or it can just send back data. Okay, and that data can come in many forms, but the two most common forms that a web server will send data back is something called JSON, or JavaScript Object Notation. Okay, it's just a way to format data. And it looks like a bunch of key value pairs, if anyone's curious. And the other one's XML. Okay, XML is another way to format your data. XML looks like HTML, but you define what the tags are all, okay? And then the other thing it can send back are just any other file, like images, PDFs, MP3s, MOVs, anything else really, like a Word document, whatever, right? And so what your browser then does with that depends on what gets sent back. If your browser gets sent back an image or a PDF, you've probably experienced this. It'll either show the image or the PDF right in the browser, or some browsers by default will just download it to your downloads folder or your desktop or whatever, right? If it's data like JSON or XML, it depends who requested it and what's going on. And then the most common thing, again, are these code files that come back. And what these code files are, it's like literally code. If you were to look at the response coming back and you opened it up, you'd actually just see code. You wouldn't see it compiled down to zeros and ones or anything like that. It's not compiled code. It's all scripted code, okay? And the code comes back, or interpreted code, or however you want to word it. And what happens is the browser then has an engine that executes that code, okay? So this is how the web works. Like generally when you're interacting with HTML and CSS and JavaScript pages, what's happening is your browser is making a request to a web server, and the web server is sending back code that is executed in the browser, okay? And that's why only one of 3 languages can be sent back to the browser, because the browser only understands 3 languages. It only understands HTML, JavaScript, and CSS. If you sent it back a Java compiled code or C# or something, it wouldn't understand what to do with that. Okay, it only understands HTML, CSS, and JavaScript. Okay. Now this is how the web works and how we're going to discuss our front end and back end. Okay. Now one thing that's missing in this diagram is what the heck is going on in this question mark. Okay, so what is going on in this question mark? Whoops, sorry. Okay. So the web has gotten very complex. There's a lot of ways to set up a web application. And I'm only going to cover 3 today. And these are by no means the only ways to set up a web application. But these are the 3 most common architectures that I for sure have dealt with. And the first 2 are for a long time, the main 2 that most people were dealing with. Okay, the third architecture and any other architectures, they're kind of surfacing and new ways to develop and getting very advanced at that point. So I'm just going to talk about 3 very common types of architectures if you get into web development. Okay, so we talked about this is your general setup of how a web works, but what's going on in the question mark there? Okay, so very typical architecture number 1 is that question mark is just a program called a web server that serves static assets. Okay, so there's a lot to dissect in that sentence there if you don't know web. Okay, so first, web server. Well, I thought you said the computer is the web server. That is true. These are 2 interchangeable concepts when we talk about the word web server. So web server is the computer that hosts a program in the red box. Okay, but the actual software that's running on that web server, that's running on that computer that allows to accept requests and allows to send back responses and all this, that itself is called a web server as well. Okay, so the computer is called the web server and the software itself is called a web server. All right, and there are a lot of them out there. You might have heard of a program called Tomcat or Nginx or Apache or Webrick or Puma or Unicorn, I think is one as well. So these are all programs that run on a computer that all their job is responsible for is accepting requests and sending back a response. That's what a web server does, okay? And the most basic version of this web server just serves static assets. What do I mean by static assets? I mean hard-coded files that just live on that machine. Okay, so the way something like this would work is you would code an HTML file. You would code a hard-coded HTML file and just throw it onto that machine and tell the web server, okay, this is where you can find this file if anybody requests it. Okay, and it could be an HTML file, it could be a CSS file, it could be a JavaScript file, it could be a JSON file, an XML file, it could be images, it could be PDFs, it could be any of these static files. And the reason we call them static is not because they can't ever change, but it requires a human to come in and recode them if they're ever going to change. Like if you want to replace the image, you'd have to manually come in and replace that image, right? Or if you want to change the HTML code, you'd have to manually come in and change them. Okay, so until someone manually goes in and codes it differently, it's static. It's just by itself. Okay, like no computer is changing it. Only humans can change it. Okay. So the way that this works is, again, you go into your browser and you type uottawa.ca/index.html. And then what's going to happen is that's going to hit the web server, and the web server is going to find that index.html and send it back to the browser. Okay. This is how the web worked for a really long time, and there's still sites out there that do this, and still a lot of, if a web application doesn't do this, probably a small piece of it does this, serving these static files back. Okay, so this is by no means dead, and the rest of the web world is based on this kind of concept right here. Okay, because everything on the user's computer up here hasn't fundamentally changed that much. Okay. All right, so that is architecture number one. Okay, you have basically a program that's running and it's sending back files when they're requested. Okay, web architecture number two is where we get into slightly more complicated, okay, but not a huge leap, but slightly more complicated. And it's really what a massive amount of web applications for maybe the last, I don't know, 15 years, maybe 20 years. I can't remember how long this has been. Last 15 years have been based on. Okay, so let me just go back to web architecture 1 for a second. So the user's computer is going to request stuff from the web server, and the web server is going to send back HTML files, CSS files, JavaScript files, JSON, XML, or other images and stuff like that. Okay. To the user's computer, again, the web server is just a black box. We don't know what's going on inside there. Okay. And in fact, when you go and request like cbc.ca, you don't know what's going on their side. All you know is they're returning you something. Okay. And as long as they return you something, they're adhering to what we call HTTP, the HTTP protocol. If I make a request to a web server, the web server is going to send me some kind of response back. Okay. So web architecture 2 takes advantage of this and saying that, okay, yes, a simple web server that serves static files back is great, but it doesn't have to be static files. Okay. And this is where web architecture 2 comes into play. So what web architecture 2 does is you still have this top part, the user's computer making requests, and it's still returning, we're still getting code files, HTML, CSS, JavaScript, or data files or other files back from that web server. But the way it does that is it runs a special type of web server that can execute server code. Okay? And what that server code is it can be one of many languages, actually. It could execute Java, it could execute Ruby, it could execute C#, VB, PHP, Python, a lot of languages. Node.js is another language that it could execute. Okay? And as long as that code is smart enough to return a response back, then we're all good. Okay? So that's what this architecture does. Is you have a web server that executes code. It would actually run, if you guys are familiar with Java or Python, it would actually execute your Java code or Python code. And as long as your Java code or Python code, it can do whatever it wants, but at the very end of what it does, as long as it returns a response, then it's good to go. Whether that be HTML, JavaScript, or CSS. So still returning the same stuff, but it's doing it using server code. Okay? So what is the advantage of this? Well, the advantage is the HTML file or CSS or JavaScript could be constructed on the fly. Okay? So your user's computer makes a request to the web server running the server code, and then it executes Java code. And the Java, at that point, on the fly, constructs an HTML file and sends it back up to the browser. Okay? Now, what's the advantage of that? Well, now all of a sudden, you have dynamic HTML, CSS, and JavaScript files. You have HTML files that could be returned depending where the user made the request from. So let's say the user makes a request from Canada. We could get Java to dynamically detect that and say, hey, send an HTML file back that says, welcome from Canada. If they send a thing that comes in from Germany, you could send a HTML file that goes back and says, welcome from Germany. Or hello to Germany or whatever, right? So this is the brilliant thing about this architecture is you can now use very powerful server-side languages like Java, Ruby, C# and all these things to dynamically construct your HTML, CSS, and JavaScript that gets sent back to the browser. Okay? Now, here's where things get really interesting, okay? What's happening is now we have two sets of code that can potentially run, okay? We have server code, okay, that runs on the server. And by the way, the web server that you pick has to be special enough to understand the language that you choose to write it in. If you're writing in Java, you have to pick a web server that understands Java code, okay? And then that Java is going to construct HTML, CSS, and JavaScript that gets sent back up to the browser. Okay, and then the browser is going to execute that HTML, CSS, and JavaScript. Okay, so we have two pieces of executing code here. We have server code that runs on the server, and then we have code that runs on the browser. The code that runs on the browser we typically call client-side code. Okay, so HTML, CSS, and JavaScript gets thrown out to the browser. Okay, now, so you might think in this situation, well, okay, well, if I'm running the Java, Ruby, C#, whatever, I never need to understand HTML, CSS, and JavaScript. Well, that's not entirely true, because if you're running Java, Ruby, or whatever, you're going to write some code in Java and stuff like that, but you're going to output HTML, right? So you might be writing Java code that then tells how to construct that HTML, and to do that, you need to understand HTML itself, okay? So we have server-side code running over here, and then we have client-side code that gets returned to the browser and executed. Okay. Now, by the way, back on architecture 1, this was still called client-side code as well. In this case, we didn't really have any server-side code running. We didn't have any server-side code that was running. We just served static client code back up to the browser. Okay. Now, in most web applications, we also want to interact with persistent data. Okay, so data that after the server gets shut down and turned back on, it still is saved. And normally, where we store that information is in a database. Okay, so part of the server code running might be that you might write some data to the database or read some data from the database. Okay, so for example, let's say somebody from Canada sends a request to the web server. Maybe we have a special message for the people from Canada. So what we might do in our Java code or our Ruby code or whatever is we might go to the database and grab that message and then put that into our HTML, construct that, and send it back up to the browser. Okay, or we may write stuff to the database. Okay, so let's say a user submits a message. We might then write some code that writes to the database. And that's why also in this architecture, we usually have a link up to a database. Okay, so we have HTML, CSS, and JavaScript and or data and images or PDFs and stuff like that running in the browser. We have server code that's running on the web server here. And then we need some kind of language to interact with that database. And a lot of times that database is a SQL database or a NoSQL database. So we need to understand those as well. You could technically also store things just in files. If you know how to write input and output IO to files, you can do that as well. Okay. So that's architecture number 2. Okay, architecture number 3. This is where things get a little bit interesting and complicated. And what's interesting about this is new web developers, people who are starting web development right now, might actually be more familiar with this architecture than the other two. The other two are kind of older, and they require, if you imagine setting up architecture number 2, there's a lot to set up here. You got to set up a web server, you got to set up a web server that understands this kind of code, you got to set up a database, and you gotta like set all that up. It's pretty complicated. If you're brand new to web development is getting a bit more sophisticated, and actually you can actually kind of do that a little bit in pieces. And what web architecture 3 looks like is actually splitting up a little bit of what we're talking about here. Okay? So this is what web architecture 3 actually looks like. Okay. So it's a lot to digest. Just follow my mouse. Okay. So what we have here is we have the user's computer and a browser, just like before. Okay? And what we have is we actually have architecture 1 sitting over on the right. Okay, so we have a web server that's serving static assets. Okay, so static JavaScript, static HTML, and static CSS. Okay, and maybe static files as well. So like images, PDFs, those kind of things. Okay. So what in this architecture will happen is a user will type something into the browser, or submit a form or something like that, and it'll go actually to the web server on the right side and grab a static asset, HTML, CSS, down to the browser. Okay, so now the browser has some HTML and CSS code, and while it's in there, that HTML and CSS and JavaScript code can do a lot of things, but the one thing it can do that's very powerful is make a subsequent web request. Okay? So that JavaScript code can then make another request to another server. Okay? And then execute server-side code, whether that be writing to the database, reading to the database, getting some data, whatever, right? And most of the time, the response is returned as just straight-up data. Okay? Now, this situation normally works when the developers of this side create what's called an API, an application programming interface, a interface between two pieces of code talking. Okay, you guys have probably dealt with APIs and object-oriented programming all the time. Anytime you use an object and you call one of its methods, you're interacting with its API. In the web world, it just happens to go across the internet to interact with that. Okay, so this is the third architecture. All right, and again, still pretty similar though in terms of where code is being executed. Okay, the server code is still running the Java, Ruby, C#, whatever. And the browser, even though they're hosted over here, really gets executed on the browser over there. Okay? So what's really important about these three architectures is understanding where the code is executing. Okay? In all three architectures, okay, let's take architecture 1. HTML, CSS, and JavaScript gets sent back to the browser in all three of these. And the browser executes it. Okay, the browser is our client, so we call that client code. It would probably be more easy to understand if we said it was called client-side executed code, because that's where it's being executed. Okay, and then on the server side, we have server code. Okay, which is this stuff that's being executed on the server. So the Java, the Ruby, the C#, and the SQL statements and the NoSQL statements, those kind of things. Okay. So that's the server side and the client side code. Okay. Now, one thing to know and think about this, I just said the most important thing to know is where the code executes. Okay. I just got a question. Let me just, how is this any simpler than the previous architecture? Shadowman, do you mean how is 3 easier than 2? How is this API setup easier than number 2? I will wait for that answer and then I'll get back to that. This is always the weird part about the delay and the like when I talk versus when it actually airs to you guys. This question is going to kind of slowly come in or whatever. So this is a great question though. I do want to answer this question. Yeah, why is 3 simpler than 2? Okay, so the question is, why is architecture 3 simpler than 2? Architecture 3 is not simpler than 2, actually. It's actually quite a bit more complex than 2. The reason why you might adopt 3 over 2, okay? Oh, sorry. Probably because I said, oh, this is a simpler way to do it. Okay, sorry, my mistake. The reason why it could be simpler is that when you start out in web development, you might only be coding this part over here. And this is why this architecture is kind of interesting, because this architecture actually allows for a different developer to develop over on the right side and a different developer to develop down here. And in fact, a lot of entire companies can be dedicated to stuff down here, and you're just programming the thing on the upper right. Firebase is a good example of this. There was a company called Sparse a long time back ago that used to do this. And there also used to be, sorry, they're not used to be, but there also are other companies that do that. So if you yourself are programming this entire thing, it is a little bit more complicated. But the advantage of this is you don't have to code the whole thing if you have a bunch of team members, and you could have a team that's dedicated to this on the left and a team that's dedicated to the thing on the right. And even further than that, if you're starting out as a web developer, there are services that provide you with the bottom left piece, and you just have to code the upper right piece. So that's why it might be simpler. And that's why a lot of tutorials do this, because a lot of tutorials will say, if you're just getting into web development, you got to learn everything anyways. You got to learn the client-side code and the server-side code. Let us handle the server-side code, and you just handle the client-side code. and we'll go from there. And as actually, to be honest, as apps grow and companies get bigger and bigger, this is kind of an architecture that a lot of them adopt because it separates the team into the client-side code and the server-side code. Okay, hope that answers your question. Okay, so like I said, it's important to know where the code executes. Okay, but one thing I want to point out, just because this might cause confusion as to when you get a job in web development or when you start to develop code yourself, okay? One thing that's important to know is that no matter where the code ends up executing, it all starts on the web server, okay? So, for example, I said here in Web Architecture 1, okay, this code is going to be sent back to the browser and it's going to execute in the browser. But that code starts life on the web server. Okay, so if you're coding Architecture 1, you're going to be coding code and putting it on a web server. Architecture 2, same thing. Even though the code gets sent back to the browser, this HTML, CSS, all this stuff like that starts life on the web server. Okay, and same thing Web 3, Architecture 3, these code files and stuff like that start life on the web server, and obviously the Java, Ruby, and stuff like that stays on the web server. Okay, so no matter where the code ends up executing, just to make this a little bit clearer, if you get a job in web development, it's not like you're coding in the browser. You're coding on the web server and then sending that code over to the browser. Okay? So this is what it actually looks like when you're coding, when you actually get to your job. Okay? So that Architecture 1, even though the code files get sent up to the user's computer, they actually live on the web server. They're just sitting on the web server, and that's where you're coding it. Architecture 2, okay, we already knew the Java, Ruby, and all that stuff and the SQL stuff was living on the web server, but now the code files are also living on the web server. Okay, and that's where you code. That's where you live your life. Okay? And then Web Architecture 3, again, even though it's going to be sent over to the browser, it starts life over on the web server, and then this stuff starts life over here as well. Okay? So that's where the code lives. Okay, so now I've been careful to use the word client and server over and over again. But we have different words for these as well that we use when we talk about web development, okay? Front end and back end, okay? So, code that executes in the browser, namely HTML, CSS, and JavaScript, is what we call client-side code or what we call front end code, okay? In the web development world. Code that executes on the server is what we call back-end code. So with this in mind, what does a front-end developer do and what does a back-end developer do in the context of web development? So in Web Architecture 1, there is only front-end code. Okay, if you're coding HTML, CSS, JavaScript, or the data that gets back, or you are, taking photographs and making PDFs, that is what a front-end developer is doing. Now, I will say, normally developers don't get involved in the images and PDFs and stuff like that. So that's kind of like not really there. It's really spending time in HTML, CSS, and JavaScript, and sometimes the data, the JSON and XML. That's what a front-end developer does in Architecture 1. Okay? Now, in Architecture 2, which is the most common thing that you do, okay, unless you, again, start to work for really big companies, or if you're starting out in web development, this is what it looks like. Again, the code all lives on the server, but the people who are coding the HTML, CSS, and JavaScript, okay, are the front-end developers, and the people who are coding the Java, Ruby, C#, VB, PHP, all that stuff, they are the back-end developers, okay? And then Architecture 3, same deal, okay? Front-end developers are coding the HTML, CSS, and JavaScript, back-end are coding Java, Ruby, C#, and so on and so on, okay? That is what front-end developers are, and that's what back-end developers are. And what's interesting is you can actually divide your front-end developers even further. There are some front-end developers who are only CSS, okay? Sometimes designers do this. UI designers code in CSS and only CSS, or maybe CSS and HTML. JavaScript is getting really, really complex, and sometimes you have fully just dedicated JavaScript developers, okay? So that's what it looks like. Now, here is the reality, though. That seems all nice and good. Okay, you become a front-end developer, you only touch CSS, HTML, and JavaScript. You're a back-end developer, you only touch Ruby, C#, whatever. Okay? Most of the time, it is not that clear cut who does what. Okay, it's very clear cut what the definition is. Front end runs in the browser, back end runs on the web server. But who does what is actually a little bit hairy. It's a little bit hairy. Like I said, in general, front end developers work on code that executes in the browser, and back end developers work on code that executes on the web server. Okay. Let me. There we go. Okay. But each of these, sorry, I'm jumping a little ahead here. Had a big nice flow there. I'm jumping a little ahead here. Okay, before we get into my big but, okay, yeah. There's a pun there. You can laugh it out loud. Before I get into my big exception here, each of these disciplines, okay, front end and back end, okay, my front end and the back end, okay, both of those have a bunch of libraries and a bunch of frameworks to help them do what they do. Okay? So CSS has its own frameworks. JavaScript has its own frameworks, okay? And this is what you will look at. So to help you write HTML, CSS, and JavaScript, you have some libraries and frameworks. For CSS, you have libraries and frameworks like Sass, Less, Materialize, Twitter Bootstrap. These are all called front-end CSS frameworks. People might ask you, what front-end framework do you use? Well, you might ask them, well, do you mean CSS or JavaScript? Because those are two different things. For CSS, we use a front-end framework called Sass. JavaScript has a bunch of libraries and frameworks as well. jQuery, React, Angular, Ember, Webpack. Webpack is a not quite a JavaScript library, but it helps with JavaScript. Okay. But you might ask, what is your front-end framework? Oh, we use front-end framework React to help us write our JavaScript in a nice, more sanitized way. Okay? So if you're a front-end developer, these are things that you might come across. Okay? A job posting might be, I'm looking for a front-end developer. This is the kind of stuff that they might be looking for. Okay? Backend also has frameworks. You have frameworks like JSP, Ruby on Rails, PHP, Express. And you also have database adapters, things that help you write SQL code. Okay, so these are all libraries, okay, that you deal with. So if you're going to be a backend developer, this is the stuff that you're going to deal with. Okay. All right, now to my exception. So what does a full stack developer do? So a lot of times, okay, a lot of times, companies don't have enough work to separate front end and back end. If you're building a really simple web application that has a form and it submits that form and writes it to the database, that might take you one day to write the front end, one day to write the back end. You can't hire, a person who only works one day a week or whatever, right? So a lot of times companies just don't have enough work to separate the front end and the back end. A lot of times companies just don't have enough money to hire enough people to separate the front end and the back end. Okay? But more often than not, the reason why we don't separate the front end and the back end is because a lot of web frameworks like JSP, Ruby on Rails, PHP, all these things, they actually intertwine the front end code and the back end code. They give you methods and functions and libraries to help you use Ruby to write HTML, things like that, to use Java to write HTML, all these kind of things, okay? They intertwine the front end and the back end code, okay? With the exception of architecture number 3, okay? Well, I guess really I'll just leave architecture number 2, because architecture number 1 doesn't have back end code. With architecture number 2, it's very common that you're working in the same code base that has the client side and the server side code. Okay, and that's because the web frameworks make it really easy to tie these things together. Okay. And lastly, the workflow might intertwine the two. What does that mean? Well, okay, if you're developing the front end code, but you need some data from the back end, you might be like, oh, okay, well, backend developer, can you go code that data that I need? And he's like, well, okay, well, it'll take me 2 weeks to do that. And then you're just sitting waiting there for that because he's busy with other things, and then you have to wait for your data, and then 2 weeks later, okay, you can code your front end. Well, that's not a really good workflow, right? So if you can code the back end, that would be nice as well. Okay, so for these reasons, okay, a lot of times you have what are called full stack web developers. And the full stack web developers are basically the people who do it all. Okay, full stack web developers understand the database all the way up to the browser. Okay, and we call it a stack because that's it looks like a stack. You have the database on the bottom, you have server side code on there, and then you have client side code above that. Okay, sometimes people ask you, what's your technology stack? Okay, well, I use a Postgres database with a Ruby on Rails backend with a React front end. Okay, that's your stack. And a full stack developer is somebody who codes it all. Okay, now the interesting thing that happens with full stack developers is it's almost like comparing a generalist to a specialist. They're really good because they have a good overall view of everything. And full stack developers know a lot of different things, and sometimes that makes them better than specialists, right? Sometimes because they understand what's going on the front end, it helps them code the back end better, right? And then, but the opposite can be true, right? They don't have enough time to spend on any individual thing, so a specialist would be way better, and separating that is better, right? So that's why you see a lot of times that early stage companies are usually dealing with full stack developers, and later stage companies are separating all these things. And in fact, it's like architecture 3 is more for later stage companies a lot of the times. Okay, unless you're using services for part of architecture 3. Okay, so that's how that works. And in fact, architecture 3 can go even further. Okay, they started talking about these things called microservices, where they almost break up the entire app into all these mini little chunks that are serving each other. So you would have a mini chunk for the orders, a mini chunk for the payments, a mini chunk for the users, a mini chunk for the products, and all doing their own little thing or whatever, and interacting with each other over the web and stuff like that. So it can get even further and further and further, right? So I myself am a full stack developer, and I love it. I love full stack development because I like variety. I like doing different things, and I enjoy all of it. I enjoy doing backend and optimizing queries. I enjoy designing front end and doing UI. I really like doing that. And what I really like about full stack web development is you have all the tools in your belt to basically launch a full blown app out to the world, right? Um, and I mean, the same thing goes for full stack mobile development, right? You might be doing the same thing. In mobile development, sometimes that architecture, you just replace the browser with a mobile app. That's one way to code a mobile application. Okay. Now I'm not saying full stack developers are better than back end or front end. I've been a full stack developer, ever since I did web development, and it's something that I very much enjoy. And this lecture was more or less just to highlight to you guys what a front end developer is, what a back end developer is, what a full stack developer is. They're all great jobs. And now hopefully you guys have a clear idea when you say the word, I'm a front end developer, I'm a back end developer, or I enjoy front end more, I enjoy back end more. You have a better idea. Now, one thing I want to be a little bit clear about is that when web started, a lot of times people considered front end just user interface. Okay, just HTML, CSS, and JavaScript to do some kind of fancy user interface things. Okay, what has happened over time with the advent of things like Angular, Ember, React, all these things, these front end JavaScript frameworks, is that more and more logic is moving to the front end. Okay, so while in the past, yes, it was a bit more of a visual job. Nowadays, sometimes the front end is just as complicated as the back end, and in a lot of cases, the front end is actually more complicated than the back end. My developers, we have a Ruby on Rails and React stack, and I would say we probably spend 80 to 90% of our time on the front end. Like we because our server has been built up, we have all the data we need. It's very rare that we actually touch the back end. So we actually spend a lot more time on the front end. So if you're kind of like, oh, I like back end better because it's a bit more, I don't know, technical or, whatever, that's not the case anymore. It's really depending on the app that you're working on. Some apps are more client heavy. Some apps are more server heavy. It just really depends where you're working in that realm. So, again, like Angular is a full blown MVC JavaScript architecture. Okay. And And again, one thing you should know is when you're coding that, again, it's running in the browser. And this is the thing, like browsers are just getting so fast and so powerful, and they're doing amazing things, right? Like some web applications that are called SPAs, or single page applications, they literally download one HTML and one gigantic JavaScript code, and that's it. And then they just start making requests in the backend for data and stuff like that, right? It's really impressive actually how these things work. If you're really interested in this stuff and you're kind of new to this, something that will definitely amp up your web development is the concept of Ajax. Ajax is something that has totally changed how web applications look and behave and make them feel like web applications. Um, and this is getting more and more complicated, by the way. Like they are starting to put web applications inside containers and pretending they're desktop applications. That's how good the web has gotten. That's how good HTML, CSS, and JavaScript has gotten. If you use Slack or Visual Studio Code, these are basically web pages that are running inside an application container. There is a framework called Electron that allows you to do that. So anyways, I'm just tossing out a lot of stuff at you now. The big take-home message today is front-end developers develop HTML, CSS, and JavaScript that runs in the browser. Back-end developers develop things like Ruby, Java, all that stuff that runs on the web server. And sometimes they're intertwined, and sometimes you're doing them both, and that's where you're a full-stack developer. And back-end developers also do database work as well. And this is all in the context of web development. Okay. So, all right. So that's the formal part of the lecture. So what I'm going to do now is I'm going to switch it over to my Q&A. You can definitely ask me any questions about the lecture itself, or you can ask me anything. So just a reminder, or for those who are new, this is the stuff I typically deal with on a day-to-day basis on the left side, and on the right side is stuff that I've dabbled in, but I'm not really an expert in. So my day job is Ruby on Rails, React, HTML, CSS, JavaScript, Postgres, React Native, Expo, Heroku, Git, GitHub, Bitbucket, and Adobe Creative Suite. And on the right side are stuff that I've dealt with in the past, but I don't know. Okay, Jack has asked me, what do I think about WebAssembly? Yeah, okay, so that's an interesting question because I am brand new to WebAssembly. WebAssembly is something that I stumbled upon because I watched a YouTuber called Chris Hawks. If you guys don't know him, you should definitely check him out. Let me see if I can bring him up here. Chris Hawks. You should definitely watch his stuff. He takes a very nice critical eye at frameworks and web development, stuff like that. What I love about him is he's one of these guys who just doesn't accept the fact that because certain things are popular, that they're good. So Chris Hawks, there he is, Chris Hawks. Check him out, really good stuff. Now I watched one video where he talked about WebAssembly, I believe, and I think I should refresh my memory just to make sure I'm not talking binary instruction format for stack-based virtual machine. Okay. So I think WebAssembly, and Jack, you can correct me if I'm wrong, but yeah, it's code that can run in modern web browsers. All right. Okay, so it's almost like compiled code that's running in the browser, because HTML, CSS, and JavaScript, they're all interpreted code, right? It's like code that gets to the browser, and then there's an engine that reads that and does something with it. Whereas I believe WebAssembly, it's like it's compiled code and runs in the browser or whatever. So that's about all I know about it. And I had to confirm just by reading it up here. I really don't have an opinion about it right now. I don't know what the advantages of I mean, I assume that compiled binary code just runs faster than interpreted code. So I maybe that's an advantage. I don't really know a lot about the advantages of WebAssembly versus not. I think what is always interesting about these things, though, is like, for me, I always am very interested to see where these things go. And I think what is a little bit tough about some of these things sometimes is mass adoption. So, can all browsers support it? There's a lot of things in web where it's like, you write it for Chrome and it doesn't work in IE and stuff like that. And I'm curious, what supports it now and what's going to support it in the future. and what the community is going to be like around it. Um, quite a few actually apparently support it. So yeah, so I to be honest, I really don't have any opinion of it. I've only briefly heard about it. Um, Idea sounds kind of interesting. I think what Chris Hawkes made a point about WebAssembly is the advantage of it is like an open standard that browsers will adopt. And he talked about the reason that's advantageous is that if it's an open standard, and if people adopt it, browsers adopt it, then what happens is that when you write code today, hopefully it won't be obsolete down the road, right? So like HTML5, for example, CSS3, those are standards that all browsers are going to support, and they're going to support in the future. And so if you code your thing in vanilla HTML and CSS, it's not going to die in 10 years from now. And I think his philosophy was the same thing here. It's like WebAssembly, if it's a standard and it's browser adopted, it's not a library that depends on the popularity. Whereas things like React, Angular, things like that, these are libraries that are built on top of JavaScript that depend on their popularity. And if their popularity dies, the library dies, and you have to rewrite your code in a different language or whatever. So his idea was that WebAssembly, I believe it's WebAssembly that he was talking about, has longer staying power, and your code will be a lot more like longer, it'll last longer basically. I think he also talked about something called Svelte, I think, which might be related. Yeah, I don't know a ton about that. I think it might be similar or adds like, yeah, I have no idea, to be honest. I'm just spitting out random stuff now. So, long story short, I do not have any opinion of it. That's why I love these chats. People bring up things like WebAssembly, and I'm like, I better go look it up. I better go figure out what the heck is going on about that. So, great question, Jack. Okay, Zach, could you talk more about Docker and microservices? Okay, so Docker is definitely not my forte. Docker is something that I've tried to understand multiple times, and I still can't understand it. As far as I understand, Docker is an engine that runs on Linux platforms that allows you to basically run these containers that are basically like the exact same environment no matter where you run it. So you have this portable container that's almost like a virtual machine, but a way lighter virtual machine. So it's almost like you are taking a Linux install with Ruby on Rails installed on it, and you can put that on any Docker install, and it'll run exactly the same. And so I guess the advantage of this is two things. So one, it tries to solve the problem of people having environment dependent issues. So if you come to work for BiteSite and we are all developing on different machines and different setups, and you're like, oh, I can't get my server to run, and then we try to figure it out for days. If we all ran on Docker is running the exact same environment for all of us. So I know that's one of the use cases for Docker, where developers will create these Docker containers that are for development, and everybody uses those, so they all have the exact same environment. The other advantage of Docker is for deployment. So if you run a web server on your machine and it works perfectly, and then you go deploy it to a web server on the internet and it doesn't work properly, that's an issue. But if Docker is running both on your machine and over there, then it will run the exact same thing, right? So again, it tries to remove this idea that different machines output different things because of the environment that they're in. Docker is this engine that runs these containers in the exact same way. Now, again, how it works, I really don't know. Yeah, Jack says basically lightweight VMs. That's the best way to think of it. It's like a lightweight virtual machine that you can basically, like, you can literally give your Docker file to somebody else and they can run it and run exactly the same way as it can. So when you talk about deployment and how this can run into this idea of microservices, you could use Docker for that, because Docker you can do whatever you want with it. But Docker, you could host a web server on it with a database on it and all that stuff like that. And you can use that to deploy a bunch of different services. Not to mention, this can be all scripted and automated and stuff like that. So the idea of microservices, by the way, is let me go back to my. Oh, did I lose my presentation? Yeah, I lost my presentation. So actually, I should be able to just go back to it. That's what the back button's for, right? So the idea of microservices is, rather than having a single web application that that has all your functionality for all your data and all your interactions. Okay, so let's say here. Okay, so web architecture 2. So in this situation, you might have a web server that is managing like 30 different database tables. You're managing a table for products, for orders, for users, for categories, for invoices, for receipts, for payments, all these things. You have all these tables and all these, and then you have all this code that manages that so that people can interact with the database and render and stuff like that. So as far as I understand, and I've only heard this secondhand, so I'm not super well versed in microservices either. You could theoretically split that up into like 30 different web apps. Okay, and you have a web app that just manages payments, a web app that just manages um, uh, products, a web app that just manages categories and users and invoice and all stuff. And you split it all across these separate web apps. Okay, and they just communicate through web services and calls over the internet. Okay, and what you could do is some of those web servers could be really simple. Okay, they could be either a full-blown web server, or they could be what are they called, like lambda functions, or these kind of serverless functions that just kind of spin up and execute and then turn down. Okay, but the idea is that you're separating all this stuff into its own thing, and then you can manage each one separately, and keep the code independent of each other, and it reduces coupling, and it sounds and it sounds really great. I have never done it myself, but it sounds really great. But I'm curious how well it works in practice and how people have done this. But you're basically separating your domain into all these little tiny services rather than having them all in one single application. And you find a way for them to communicate with each other. And with the web, it would be web services that talk back and forth with each other. So that's my understanding of web services. Or sorry, microservices. And to deal with that, you could use something like Docker. I don't know if you asked this question together because you're looking at how they tie together, but Docker would be really advantageous there, because you could have Docker, you could have a container for all those microservices, and you'd be able to deploy them all really quickly, right? So that would be one way that I see the two being related. So just to recap on that, WebAssembly, microservices, and Docker, I really don't know that much about. So that's about the extent that I can talk about that. So can you talk more about backend, i.e. the different layers, repositories, services, controllers, ORMs, etc.? Yeah, that's a great question, Mark. So we talked about how the front and the back end, they themselves can be dissected even further than where they are. So it really does depend on the web framework that you use. So I'm going to talk about this from the perspective of Ruby on Rails, and it's pretty similar for other things as well. So, whoops. Okay, so let's grab a diagram here. All right, I can't edit this. Okay, so I'll just do this in Sublime. We'll do some visual diagrams here. Okay, so like we said, we have the user, and the user interacts with the browser, and the browser makes a call to the web server. Okay, so what does the web server look like? Okay, so in the web server, that's the computer, just to be clear. The computer is running a piece of software called a web server. And what a web server does is it listens on a port. Okay? So a web server is a program that's just running perpetually until you stop it, and it's listening on a port. Okay? And a port is basically, think of it like a virtual location on your computer. Okay? So your computer, you can picture like a house, and inside that house you have a bunch of rooms. Okay? So same thing. So a computer has an IP address, so that's the house, and inside that computer there's a bunch of ports. Okay? So like a bunch of rooms. So it's a location. Okay? So a web server is listening for ports, and by default it listens on port 80. Okay? When you do development, it usually listens on port 3000, but a web server is listed on port 80. And what happens there is when a browser makes a request, it's making a request to an IP address and a port. Okay, so when you type in http cbc.ca, you're really typing in this cbc.ca port 80. Okay, because 80 is by default, and then this gets converted, by the way, into some kind of IP address. Okay, so really it's going to go to this IP address, which is this computer here, and it's going to go to port 80. So that message goes into port 80. Okay, and actually this is it'd be the other way around, port 80. Okay, so there's a lot of ports on this computer. Okay, so it comes into port 80, and this web server is listening on that port, and it gets that. Okay, now here's where things depend on your web framework. The way that Ruby on Rails works is depending on the request that comes in, so what was the URL that they requested, what was the type of request that got sent in, it's going to execute a method. Okay, so somewhere in the Ruby on Rails code, there's a method that it's going to execute. Okay, so then what you have server-side code that executes. Okay, now the server-side code, the only job that server-side code is supposed to do, I shouldn't say the only job, the only thing it's required to do is the very end, it sends back a response back up to the web server, and the web server is going to send it back through port 80 back up to the browser. Okay, so whatever this code does, okay, the last thing it has to do is send back a response. Okay, now this code here could do anything, and one of the very common things it does is probably read or write to a database. So what you're going to do there is you're going to connect to a database. So in our case, let's say a SQL database. And you're going to actually execute a SQL query. Okay, so a database, if you guys don't know what databases are basically, think of them as like fancy Excel spreadsheets. Okay, they're just like tables of data that you can store permanently, and when you turn off the computer, turn it back on, it's still there. Okay, and to interact with that data, if it's a SQL database, you can do SQL code, basically SQL queries. Okay, so this code here might say something like execute this SQL query. Okay, so that's an example. So what that's going to do is it's going to go to the database and either write to that table or fetch stuff from that table. Okay, so this is going to execute query and potentially return results. Okay, and when those results get returned back to the server code up here, the server can do whatever they want with it. So let's say they fetched a bunch of users, they can now use those users in the response. Okay, or something like that. Okay, or let's say they're writing data to the database. As long as they got a successful write, they could then go back in there and say, okay, we got a successful write, and send that back into the browser. Okay, so that's the server code there. And then that's pretty much it. This is what a full stack web application looks like. Okay. So one thing you can do is you can introduce a layer that's part of the server code. Okay, part of the server code, but is exposed to the outside world through the web requests. And that's what, again, we call an API. Okay, so an API is basically a way for a browser to make a request to a web server that will hit this and then execute this code. Okay, so that's what an API is. And usually, if this is open to the world, okay, let's say we made this, okay, doesn't matter who requests from it, we'd usually call that a web service. Okay, a web service is nothing more than a open URL that anybody can make a request to. Okay, so if you're coding a web service, you're basically coding this and a URL that somebody can request to. That URL, we usually call that an endpoint. Okay, so the browser makes a request to an endpoint. Okay, and you code the back end of that. Okay, so that's what a web service is. And there's two main types of web services. There's what are called RESTful web services, and there's what are called SOAP web services. RESTful web services follow a certain convention to interact with, and they are the best type of web services because they're really easy to interact with because they just respond with plain old JSON or XML data. SOAP gets a little bit complicated because you basically get a object that gets sent back and you reconstruct it on the other side and stuff like that. So that is really what the back end layers look like. So it's really all this stuff here, but really it's just server side code and database. Usually that's what we're dealing with there. So now one thing I should mention is, again, the browser can interact with more than just one server. Okay, it could interact with a server that you code, or it could interact with a server that someone else codes. Okay, and that's where things, again, like Firebase comes in. So Firebase is, among a bunch of other things, the Firebase database, okay, is a service that Google has coded that allows you to not need to code the backend. They actually give you a service that if you hit these endpoints, we'll write the data for you, we'll get the data back from you. Because a lot of times the server code is just that. It's kind of like it's just a dumb read write repository. It's just kind of like, oh, it's just a place where we store data and write data. It doesn't need to do anything complicated. Okay, all our complexity will live in the client. Okay, and those are what we call like client heavy like code applications or whatever. So if you're not going to code this yourself, you can use services like Firebase and stuff like that, right? So that's a service that you can use. Mark, I don't know if that answers your question. If you have any specific things that you were wondering about, but that's kind of what the stack of the backend looks like and the things you look at. Oh, you asked about ORMs. What are ORMs? So ORMs are object relation mapping tools. And so what an object relation mapping tool is okay. So most of you guys know what object oriented programming is like. So you might have, okay, we're going to give you a brief, okay, we still got time. These things usually go for an hour and a half. So we're going to talk about ORMs here. What is an ORM? Okay, let's actually leave this up here. Okay, so I talked about how we might want to execute some kind of query on the database to fetch results or to write results to the database, right? But I kind of like just did this generic SQL statement without really explaining how this actually works. Okay, so let me give you an example of how that actually works. Okay, so let's say we have an object, and again, I'll use Java because, again, I don't know what languages you guys use. But again, if I get the syntax wrong, you can forgive me on that. Okay, so let's say we have a class person. Oh wait, this is Ruby. I'm already coding in Ruby. Okay, so, and let's say we have an age and a name. Okay, and then we have a constructor. Okay, and is it self or this? It's this in Java, right? Can't remember. It's been a while. Okay. All right, so let's say we have a basic class like that. All right, and then let's say we have, public static void main. Yeah, we have a main function. I really don't know how to write this, but again, you guys get the idea. And let's say in this, we want to execute some write to the SQL database. Now, to understand this, you guys have to understand how SQL databases work. Okay, so let's say I have a SQL database sitting here. And for SQL databases, you'll have tables. Okay, so let's say I have a table. Okay, so let's say I have a table. It's already created, and the table is called persons. I'm going to say, rather than people, persons, and it has a column called name, age, and a column called name. Okay, and the reason we use a database instead of just the objects in Java is because Java, again, when you turn off the program, your data's gone, right? A database is persistent, right? But we're going to make one-to-one kind of mapping here. Okay, so we have that, and so we might have a table that looks like that, and so actually, let's also give it an ID. Okay, so let's say we have the first person and the age is like 23, and like the name is Casey. Okay, so that's a table. And let's say we want to insert a new record into this database. Okay, so to insert a new record into the database, we have to run what's called a SQL query. Okay, SQL query is its own language. Okay, so it looks like this. Insert into persons. It's been a while again since I've done this. I believe it is, yeah, values. No, wait, insert. Man, it has been a while since I've coded this from scratch. How do we do insert statements? Insert into table name column values. Right. Okay. Insert into persons, and then we'll say we're gonna specify the age. We're gonna specify the ID, the age, and the name. Okay. And so the ID will be 2, the age will be 20, and the name will be Mark. Okay. So that query will insert another record in here. Okay. Of 2, 20, and Mark. Okay. So the question is, we want to do this from Java though. Okay. So Java might have something called a SQL database adapter. Okay. So it might have something called like, PostgreSQL.SQL or something like that. It might have some library like that. I don't know what it is exactly. And what it might have is something to execute a SQL statement. Okay. So PostgreSQL might have a function called like connect to database, and you specify the database. And then you might do, I don't know. And then you might do execute statement. It's not exactly like this, but it'd be something like this. And so what we would do is we would construct this. Okay. So to do that, we might instantiate a person first. So we'd say like person Mark equals new person 20 Mark. Okay. And let's give these guys an ID as well. Okay. Okay, so we have this and ID too. Okay, so now what we can do, let's say we have a bunch of getters and setters. Okay, I'm not going to code them all, but let's say I have a bunch of getters and setters. Okay, so now we want to execute this SQL query. So what we'll do is we will type this out. We'll say insert into persons, ID, age, name, values, and then we're going to do a bunch of concatenation here. So plus mark.id, comma, plus mark.age, plus mark.name, or I guess these would be like get name and all that. Or we could also make them public, but it'd be like get ID, you guys get the idea. Okay. Now, by the way, for those of you who try to do this at home, be very careful of this. There is an attack called SQL injection that this is vulnerable to. So just don't code this directly. Look up SQL injection before you do this. Okay, so we almost got that, and then we needed a close parenthesis, and then we're done. Okay, so that's good. So that is how your code might look. Now we might be able to make this a little bit better. We might be able to put this directly in the person class. That might be nice, right? Maybe we have an instance method called insert. Okay, and then all that does is do the exact same thing that this does. We'll just paste it up here. Okay, and then rather than mark, it becomes this. Okay, so that's good. So then we can just call mark.insert. That's looking pretty nice. Okay, so that's pretty good, right? So ID, age, and name, right? Now, this is all well and good, but that's just for the insert. Okay, if you want to do a select, you'd have to write that. Select is like fetching records. If you want to do an update, you'd have to write that. If you want to do a delete, you have to write that as well. And if you look at the way we're writing it, if we were to do this for another class, say like product or invoice, it would look very similar. It would just have a lot of different fields, right? So it'd be very similar. So what an ORM is, an ORM is basically a library that does this for you. Okay, an ORM is mapping an object to a relational database. So it does this whole mapping for you and provides these things for you. So that library may come in the form of like a base class. So extends ORM base class or something like that. Okay. And it has all these methods, and it knows the fields that you have and knows the database table names, and as long as you name them all the same way, it'll do it all automatically for you. So that is how ORMs work. ORMs are all about how you can map an object in memory into a relational database record in the database. Okay. And usually what the way they work is they provide you with all the methods to do that, to do inserts, updates, deletes, selects, to do all those without hand coding the entire SQL statement yourself. Okay, so hopefully that answers what an ORM is. If you guys have any questions on ORMs, definitely let me know. Okay, what's the best way to learn about SQL databases? Okay, best way to learn about SQL databases. So what you want to do is download a free install of either PostgreSQL or MySQL. They're both open source databases. I don't know if they're open source, but they are definitely free. So PostgreSQL or MySQL. Okay. Actually, there might be even ways to try this without downloading them directly. If you're on a Mac, there is a great program called Postgres.app. Okay. Postgres, unfortunately, is one of these programs that's a little bit old school in that you install it and you use command line to install it and you use command line to interact with it. And so sometimes it's really hard to understand if it's installed, if it's running, if you set up everything properly. Postgres app for the Mac is a really nice visual way to make sure that everything's running well. I have it running here. You can see I have it running here. So install one of those. And honestly, the easiest way to start is just hit up W3 Schools. Yeah, I mean, this first thing I queried here. This is a great tutorial on how to use SQL. It's actually a pretty easy language to start learning because basically what it says, how do you insert a record into the database? How do you update a record in the database? How do you delete a record? How do you and if you understand those basics, that's a great way to get started to learn SQL databases. So you might be able to do it. You might even be able to do it somewhere like on the web, just literally like try SQL or something like that. I wouldn't be surprised if there's a web app already built for this. Try it editor. Yeah. Yeah. Okay, there you go. So you can try it out in W3 Schools. So you can insert records into this table. You can run queries on this table and stuff like that, and do all that stuff. So that's probably the best way to learn about SQL databases. Just go to W3 Schools and literally start doing queries. If you're able to install Postgres or MySQL on your computer, then create a new database and add tables to it. One thing I should mention that always seems to get overlooked by people who are new to SQL databases, I think I made this mistake myself. Postgres and MySQL, whatever, they are database servers. Okay, so it's a program that runs, and they allow you to interact with the data. What you typically want to do is you want to create a database for each application that you build, and some applications might have multiple databases. Okay, so if you build a web application that interacts with a database, or you build a desktop application that interacts with a database, you have a database just for that application. If you build another application, you create another database for that. Do not make the mistake of putting all your tables for all your applications in one single database. It's a very easy mistake to make if you're doing this for the first time. Just know that databases, you generally are at least one per application. Okay, so all right, we're coming up to 9:30 here. Happy to answer a couple more questions if anybody has any more. If not, I will start wrapping up though. But yeah, again, this is great, guys. Definitely viewership increased as we kind of went on here, so really happy about that. Really enjoy these things. I really enjoy talking about these things, and it's kind of unfortunate because I think with the Q&A, sometimes I go a little too surface. It's a little bit hard sometimes to teach these concepts from scratch. So I'm still kind of learning that. I'm still trying to figure out what the best way to answer these questions are. Is it to deep dive a little bit? Because if we deep dive, then maybe you guys actually get more from my answer. But then I don't get to as many questions, so that's a little bit tough. The other thing is it might inspire me to formalize the lecture for next week. Like I only decide what I'm going to lecture like kind of a couple days before. So maybe we do a whole thing on SQL databases next week. I know university students don't typically take databases till third year, so maybe that's a great thing to learn now, right? Is to teach you guys some SQL databases. So again, if you guys have topics, definitely don't be afraid to tweet at me or again send a message in this chat here about things that you guys want formal lectures on. Happy to talk about anything that I happen to know about. Any of these topics that I just talked about, if you want a deeper dive on any of these, definitely happy to do them. If ORM really intrigues you guys, we could code an ORM from scratch. We could do something like that. So things like that. Definitely happy to answer any questions that you guys have, and happy to tailor this to what you guys think is more useful. Now I know a lot of you guys are about to go into exams. So if you guys would prefer this on a different night, let me know. But as it stands now, I think I'm going to continue this Thursday nights at 8 p.m. Again, be sure to subscribe and hit that bell icon so you're notified when I do go live. The more interaction we have, the more we can drive this, the better. And definitely spread the word, like I said. And what was I going to say? Yeah, and again, if you miss any of these sessions, a couple minutes later it does go live on YouTube. And those who are late joining us, I do want to remind that there are two versions of Casey Lee Live right now. There's Casey Lee Live and Casey Lee Live Software Edition. That's what this is. This is the software edition. The other one is an acoustic concert. Happy for you guys to join, but it's a very different thing for sure. If at some point I think doing a deep dive into databases and things like Oracle databases is if ever. Yeah, deep dive into databases. Okay, maybe we do databases next week. Just so you guys know, Oracle is another SQL database. So if you learn PostgreSQL, MySQL, Microsoft SQL Server, or Oracle, most of the skills are transferable. There are some things that are specific to Oracle, some things specific to Postgres, something, and so on. But if you learn any one of those, most of the skills will transfer to any one of the others. So definitely we can deal with that. So yeah, it looks like we're getting some votes here for SQL databases. So why don't I dive into SQL databases next week? I think that would be a great lecture. We'll fire up a database, we'll create a database, and we'll do some queries, and we'll learn how to learn all that. So there are definitely more complex things we can get into, but we'll kind of do an introduction. I'll see if we have time to get into joins. Joins are where databases get really interesting. But if we don't have time, at least you guys will understand how to insert records, how to delete records, how to do those kind of things. We will definitely hit that up. So. Okay, so I think that's pretty much it, guys. I will stay on the chat for 5-10 minutes after I end the live stream. So definitely, if you guys have any more questions or any more topics or suggestion or whatever, definitely let me know. Really want to thank you guys for doing this. Really want to is there anything that we should prepare on your end? I will answer that question. Really thank you guys for making this happen. I've had a lot of time with this whole COVID-19 thing to kind of get into old hobbies and start new hobbies like this. And this would be nowhere near as fun if I didn't actually have a live audience watching. So really, honestly, guys, thank you so much for doing this. I hope we can grow the audience. I hope we can do more and more of this stuff. I will try to, again, bring in different people and stuff like that. It's a lot of work, and definitely there's a lot to do. So I'm not going to promise anything, but I will try at some point, for sure. Is there anything that you guys should prepare now, knowing that we're going to do some kind of SQL thing? I would say if you guys can get PostgreSQL or MySQL installed. So if you're going to use PostgreSQL, you're going to want to also look for a program called pgadmin. Pgadmin is a visual user interface, it's a graphical user interface, a GUI, that you can interact with Postgres really easily. So that's the one I'll probably be using. So I'll be using this, by the way. I'll be using Postgres and pgadmin. MySQL, you can get that installed too. I don't know if Oracle is free. If it is, you can try that too. And the other one is MS SQL Server, Microsoft's version of this. So any of those SQL databases, if you can get those installed and running, that would be great. If you can try to create a database, so step 1, install. Step 2, try to create a database. Okay, that's pretty much it. If you can try to create a database, you're sitting in good shape. Um, I probably won't have time to help out getting you guys set up. But even if your environment's not set up, you'll probably be able to follow along pretty easily. SQL, its basic instructions are not too not too complicated, to be honest. The introduction stuff. Yeah, don't get me wrong. SQL can get crazy. Can get very crazy. But the stuff that we'll be doing next week, even if you don't have your environment set up, you'll be able to follow along for sure. So. Okay, awesome guys. It looks like an hour and a half is a great kind of time frame to do this for. So we'll aim for an hour and a half again next week. So next week, Thursday, right before Good Friday, actually. So hopefully you guys can still join. And again, spread the word. Let me know if there's anything else you guys want to cover. Definitely send me tweets or whatever. Don't forget to subscribe to the channel. Don't forget to hit that bell icon. Definitely sounding like an annoying YouTuber now. But again, definitely helps me out. So. Thanks so much, guys. It's been really fun. I really enjoy this. We'll definitely do it again next week, and we'll see how much we can go from there. Thanks so much. We'll see you guys later.